So, in this lab what we will be teaching about you would be on how to interface sensors and actuators with Arduino. Now, you already have used Arduino. For people who do not know what is Arduino, we will be discussing about that particular board, and you will be looking at how we can we can interface these actuators with those particular board, how can interface the sensors with the Arduino board, and this is like a practical class. So, you know, and Arjun who is my teaching assistant will be taking this class. So, learn about it. Like I am sure that lot of universities and colleges they teach Arduino as a part of their experimental exercise, particularly for electronics students. So, but if you still do not have idea, it is fine, use this lab as an practice lab for understanding how can you interface several sensor actuators with the Arduino board, right. I will see you in the next lab class. Till then, you take care. Bye.
Hi, I am Arjun, a TA for the course Sensors and Actuators. So we will be having a small tutorial on how to use an Arduino board, that's a microcontroller which can be used to interface our sensors as well as control our actuators that we have discussed earlier. Okay. So an Arduino board is nothing but a microcontroller which can be programmed. It is a development board basically. So we will be seeing how an Arduino board is used, the features that we can utilize, as well as the Arduino IDE, the software platform that we use to control the Arduino. Okay, so we will have a look into it. Now we will be seeing a Arduino board. So in the previous lectures we must have discussed about different types of Arduino. So you must have heard of Arduino Uno, Mega, Arduino Nano and other boards. So what you see here is a Arduino Mega board. So you can see here it is written Arduino Mega 2560. Okay. So there are different boards, basically like either the capacity changes or the number of pins or size varies according to the applications. So what we have here is an Arduino Mega board. Okay. Arduino Mega board has 54 digital pins, digital input output pins. So we can take both inputs as well as outputs via these digital pins. Also we have 16 analog pins also. So using these analog pins over there, we can actually take analog inputs, okay, analog inputs, and also use them as digital outputs also. Okay. Also we have 16 PWM pins among these digital pins which can be utilized to control the speed of motor and other things. Okay. You can also see the Atmega 2560 IC which controls the Arduino board. It becomes the brain of the Arduino board. Okay. So Arduino Mega has a major difference between compared to Arduino Uno. It has 4 UART ports. For Arduino Uno we can take TXRX from one set of them, while we have 4 of them for communication, serial communication. Okay. Now you can see a power jack over there in the Mega where we can power it up. Okay, you can provide up to 15 volts. It already has a voltage regulator and a current regulator inside it. But a safe operating voltage is 9 to 12 volt, so it's better to keep it that way. You can the Arduino to Mega works at 16 megahertz, and you can see the crystal oscillator over here. Okay, so these are the basic constructional things of the Arduino Mega. It also has some 5 volt, 3.3 and ground pins which we can utilize for small LEDs and other things that we are going to show you. Okay. So now I am going to connect the Arduino Mega to my laptop. This symbol over here is for the shortcut for Arduino IDE. So Arduino IDE is the tool that we will be using to program the Arduino Mega or Uno or any of the Arduino boards. Okay. So I am opening it. So if this is the genuine software, that's the Arduino Genuino. Okay. So this is how it will come. It's a sketch. So this is the window of the Arduino IDE where we will be doing the programming. So the programming language over here is based on embedded C. So it's not the pure embedded C, but a Arduino variant. But if you have a logic in Arduino, the embedded C or C++, you will be it will be very easy for you to catch up with it. Okay, now you can see here, I will just erase the font. Okay, so you can see here. So by default there are like two functions over here. You will be familiar with functions and other things. So there is one void setup here and one void loop here. So why by default there are two functions over here? So this is because like consider we are doing some experiment. Okay, so there will be some initial setup, or we have to set up a facility or a lot of equipments, or the things that we have to do the experiment with. So there will be a setup process before any experiment, right? So this void setup function is something similar to that. So this setup or the setting up process will only happen once during an experiment. So similarly in Arduino also this void setup runs only once. So this setup function will be the place where we will be doing all sort of initial arrangements and other things. I will let you know like what kind of things are those. For example, like I have already told you, like there are digital pins, there are analog pins, there are PWMs, we can generate PWM signals and a lot of things like that. Also we will be able to transfer data serially. So all those facilities are there with the Arduino board. So in the void setup, what we do is actually we will say that a digital pin is going to be used as an input or as an output. Similarly, if we are using an analog pin as an input or output, well, like similarly all the setup process comes under the void setup over here. And then there is void loop. So once we start any experiment, what we do is like we might do multiple iterations with a multiple change of cases and other things. So that process repeats over and over. Similarly in the Arduino also we have a void loop that repeats over the entire duration of the runtime as long as the Arduino is powered up. Okay, so there are two main functions in the Arduino IDE. One is void setup and one is void loop. Okay, now we will do some sample codes and see how it is implemented in the Arduino. So one of the most common examples is a Blink program. So you can see over here, I am taking a Blink code. Okay, you can see here in the file menu there are examples. A lot of examples will be there. Once you Arduino has support from a lot of libraries because a lot of developers use Arduino. So you can see different other drivers and other things are interfaced with Arduino, and once you install the libraries you will get examples for all. So I am just taking an example of basics and Blink. So I am going to show you how a LED can be blinked using an Arduino program. Okay. So you can see here in the void setup we are defining pin mode LED built-in comma output. Okay, so it means that LED built-in here is a variable. Okay, so in Arduino Mega it's understood that it's in usual Arduinos LED built-in is connected to pin number 13, digital pin number 13, but to avoid confusion I am going to put say 13. So since if you are not aware about that, I am just converting it to 13. So it says that, so this is how it works in a void setup. Okay, so there is pin mode 13 comma output. This means that the 13th pin, the 13th digital pin is an output pin. So if we change this to input, it means that the 13th pin is a input now. So this is what we set up inside the void setup function. Okay, so right now I am putting this as the 13th pin as output. Okay, and what you see here is the void loop. So these are the one of the functions that, like you can see, digital write 13 comma high. So this is the one of the functions that we use to control the digital pins. Okay, so the digital write command is used to tell the Arduino that when this command is being called or this function is being called, make the 13th pin high. So you know it's a digital pin, so it has only two states, either high or low. So when this command or function is being called, it will automatically make the pin state, the pin that is referred here, high or low depending upon what comes over here. You can see a similar line here, digital write 13 comma low. Okay, so this is basically like make the LED that is connected to the 13th pin on, and this is to make the pin LED off. And you can see a delay function here, which is a common function we use. So delay is used to delay the code run for a while. So the void loop will be running infinitely, like a infinite for loop or while loop. So in between, if you want to delay or something, you can put a delay like this, and whatever number that comes in the braces are in milliseconds. Okay, so 1000 means it's 1 second. So what this code will do is, initially it will make assign the 13th pin as an output, then after that it will start running into the void loop for infinitely, and the first step it will do is it will make the 13th pin high. So I am going to connect a LED to the Arduino board and pin number 13, and also in series I am connecting a resistor also to prevent it from getting damaged, since the high in the high state of the Arduino is 5 volt, which is not desirable for the LED for a long time. Okay, so what we essentially want after this program is the 13th pin will be high, that means the LED will glow. It will stay like that, or it will glow for 1 second. After that, that LED will turn off for 1 second. Again the void loop repeats itself, so it will be like a LED blinking at an interval of 1 second. Okay, this is how the code works, and you can see multiple buttons over here. You can set the you have a lot of options over here, like increase the font size and other things. Also in the sketch you can see the commands compile, upload and other things. Also there are button here, this is the compile button. So once you have done the code, you can just press this tick button and you will show the progress bar here, and it will be written done compiling if there is no errors. And if you press this button, the code will be uploaded to the Arduino board. So in the tools, you have to note this one, very important. So you have to select the board. So since I have connected an Arduino Mega, I have to choose under this board as Mega. If it was a Uno, you have just select Uno. It's Mega, so we are selecting Mega 2560. And also you will have to select the COM port. So since only one Arduino is connected now, it's showing COM port 11 only. So I have selected that. So these are the important steps that you have to make sure you have done it before you upload the code. Okay. So now I am going to upload the code. So once I start uploading the code, you will see that the data is being transferred to the Arduino, and it will start the RX and TX, the receiver and transmitter LEDs will be starting to blink, showing that the code is being uploaded. After the code being uploaded, the LED attached to the pin 13 will also start blinking at the interval of 1 second. So I am going to press this button. So as you can see, since I uploaded the code, it blinked very fast, the RX and TX pins over there, LEDs over there. So I will just show once again, show it for you to show that the RX and TX are blinking very fast. You can see that red LEDs that blink very fast, so it means that the code being uploaded. Now you can see that white LED that is connected to the pin number 13 is blinking at the rate of 1 second. Okay, it's turning on and off at an interval of 1 second. Also you can see a red LED in Arduino also being blinking at the same rate at the same time. So since I have already mentioned that the built-in LED in Arduino Mega is connected to the pin number 13 and we have used the same pin, so both LEDs are being blinking. Okay, so that's how digital write command, or how we will this is how we will be giving a digital output in Arduino Mega or any of the Arduino boards. Okay, now we will see some other functionalities also. Now I am going to show you another example. So we have seen how we send out digital outputs through Arduino Mega. Now I am going to show another example how we can take a analog input. Along with this, I will be showing another functionality called as serial monitor. So in the tools you can see something called a serial monitor. So the serial monitor function is used to display some data that Arduino will send to the PC, and we can view it. So it is basically used as a method to see some data that we are acquiring from the Arduino. Okay, so in this experiment I will be connecting a potentiometer to analog pin A0. I told you earlier that there are 16 analog pins, out of which we call the digital pins from 0 to 53. There are 54 pins, so 54 digital pins. So they will be named as 0 to 53, 0, 1, 2, 3 like that. So we already declared them as like pin mode 13, etc., etc. So when it comes to calling the name of analog pins, we name it as A0, A1 up to A15. Okay, there are 16 analog pins. Okay, so A0 to A15 makes 16 pins. So I will be taking data from one of the analog pins. I will be using this to control the brightness of an LED that is connected to pin number 7, which is one of the digital pin as well as the PWM pin. Okay, so we can control the brightness of LED. At the same time, I will be using the serial monitor to print the value that we receive from the potentiometer. Okay, so when we receive some data or when we acquire some data from an analog pin in Arduino, the value range or we will be getting it as voltage only, right? So Arduino works at 0 to 5 volt. So when we acquire any signal through an analog pin, what we get is like a range from 0 to 1023. Okay, sorry, 0 to 1023. That means actually there are 1024. Okay, 1024 values. So this is what this 0 to 1023 value is equivalent to 0 to 5 volt when it comes to voltage. Okay, so that's what we will be converting over here. So this value will be the range that we are going to get from the analog input. Okay, and when it comes to a PWM output to control the brightness of the LED, the range is equivalent to 0 to 255. Okay, so the resolution in input as well as output is different. So when it comes to PWM output, it varies from 0 to 255. When it comes to analog input, it is from 0 to 1023, and the voltage corresponding to it all is 0 to 5 volts. So this is the basic understanding. When you go through some Arduino tutorials, you will be getting more idea about it. We need not discuss about this because our course is basically sensors and actuators. I am explaining this all to so that we can interface some sensors and show you how it works. Okay, cool. So we will do an example now. Okay, I am going to write an example here. So you can see that I am typing some function called as serial.begin, and in the bracket I had put 9600. So this is called the baud rate, or at the rate at which the Arduino transfer data through to the laptop. Okay, so this is one of the minimum baud rate that we can choose. There is 4800. You can see over here when we connect to the serial monitor which all options are here. See, there are 300, 1200, 2400, 4800, 9600. We can select any one of the rates. I am just selecting 9600 only. So I have typed the serial communication. So once this function is being called, serial data will be sent from Arduino to the PC, and we can use it for multiple purposes. Okay, so that's there. Then I am going to put one more thing. So I am going to define one of the pins where we have connected the LED. So I am saying pin mode. Okay, I am connecting the LED to the 7th pin. So I am putting it as output. So since an LED is an output. Okay. Also similarly I am doing pin mode A0, where I have connected this thing potentiometer as input. Actually we need not define A0 as input because by default the analog pins are input only, but still for clarity I am putting this as input. Okay. Now Okay, since we only need to start serial communication, then make sure that the 7th pin is an output pin, so that where we have connected the LED. All the commenting function and other things in C++ also works here. So I am saying it's LED, and this is potentiometer. Okay, so in the void loop I am going to take the value from the potentiometer and control it and use it to control the brightness of the LED. Okay, so I am defining some integer x, and I am going to store the value of the potentiometer into it. So I am going to use the function analog read. The code in Arduino is case sensitive, so you have to take care which all letters to be capitalized and other things. You need practice to write it by hand. So by practice it will all be clean. So I am going to put so this analog read function will, when this function is being called, it will store the value of the potentiometer in the range of 0 to 1023 into this integer x. Okay. Now, as I have already said, this integer value is in the range of 0 to 1023 now, because analog read has a resolution of from 0 to 1023. Okay. And when it comes to PWM output, we only have a range of 0 to 255, which is like 1/4 of the analog read resolution, right? So I am going to say define another value y, and I am going to store this is equal to x by 4. I am just doing a mathematical function over here. I will show you another function also on the later stage. Okay, and I am doing is what I am doing is like I am writing analog write, because now I am going to the for using the PWM functionality of a digital pin, we have to use the analog write function. Okay, so I am going to say 7th pin comma y. So this means that if this y is 255, that means it's equivalent to a digital write 7 comma high. That means the LED will blink or glow at maximum brightness, and if the value y is 0, it's equivalent to low. So since this value y varies from 0 to 255 now, the brightness of the LED will also vary. Okay, so if I upload this code now, the LED will be the brightness of the LED will be varying continuously as we change the value of the potentiometer. But I am going to put some other function also here, since I was telling you how to print the value that we get from the potentiometer directly. So I am going to print the value x over here, so that you will see how we can display the value that we get also in the serial monitor. So I am now going to upload the code here. So I will show you how it will look when we change the value in the potentiometer in the serial monitor, as well as how the brightness changes in the LED. Okay, I am going to upload this code. First we will compile it to verify, yeah, so it's done compiling, so it's done, there is no error. So I am going to upload this code. So you can see this green progress bar. Okay, it's done uploading. Okay, now first you can see on the left side the LED is blinking. That means the potentiometer is sending some value that is not equal to 0. Okay, now I will show you the serial monitor. Under tools I am going to show serial monitor. Okay, you can see some value over here, right? So this is the value of the potentiometer in the range of 0 to 1023. Okay, when I am turning the knob of the potentiometer now, see, like I am turning it in the clockwise direction. That means I am increasing the value of the port, and you can see that the value being changing. Okay, that means the voltage is increasing. So I am actually decreasing the resistance in the potentiometer. So the voltage is increasing. You can see it is increasing. Another method, like here you can see the baud rate that we have already chosen. Okay, another method of seeing this, since this is a waveform, Under tools we have something called serial plotter also. So you can see the scale over here. It is the problem with the serial plotter is that it will auto adjust the scale very much, so it's quite confusing. But you can see when I'm not turning the potentiometer, the value almost remains constant. The value from 849 to 852, that's what it's in between. As you can think of, like say 0 to 1023 is approximate to around 1000 values, and 5 volt is being divided into 1000 values, right? That is around like 0.005. So that much accurately you can measure the voltage, or in terms of around 5 millivolt you are able to measure it. So that is the kind of accuracy that we are getting. Now if I am turning this thing, turning the potentiometer, you can see the value being increasing, right? And also if I turn it the other way around, it will start decreasing. I will show another trick to stabilize this one. It's not a good method, but I will show you. At the same time, before that, you can see that the LED is brightness also is decreasing or increasing. So now I will start decreasing the brightness. So I am turning the potentiometer in anti-clockwise direction. So the value is being decreasing here also in the serial plotter. Slowly you can see the brightness of the LED also is going down. See, the LED is almost dim now and it's off. So once it reached the zero value of the potentiometer, the LED went low. Now we are like increasing this thing. Okay, now yeah, this is how it works. So if I just plot some other value also, this is just whatever I am showing now is just to just for you to understand this. So you know the value changes from 0 to 1023. Okay. So if I plot this one, okay. So I have added some other part of code over here, this much, to show you that. So here what we do is like we are just printing the value 1023 and 0 in the serial plotter along with x, so that the scale won't change much. So you will understand very clearly. See, this is the 1023 line and this is a 0 line. So now when I change the value of the potentiometer, you can see it actually increasing. So it's not scaling. This is not a very recommended method, but I am just showing that, showing this because the scale won't change now here. Okay. So if I turn in the anti-clockwise direction, it's going to reduce. This is how we take analog input and print it in a serial monitor or any of the functions. Instead of this y is equal to x by 4, I told you earlier, I can even do something else. I am commenting that statement, and if I put into y is equal to map of, this is another function that you can use here. Okay, so I am putting map. So x is in the range of 0 to 1023, and I am going to scale it to the value of 0 to 255. So this is another function that we can use alternatively. You will use this map function a lot of times when you do some complex program and other things. So now the value y is mapped with respect to x in this range. So x is in the range of 0 to 1023, and you are going to map this value in terms of 0 to 255. It will show you the same results only. See, it's the same thing only. This is an alternative method. So if you do not know if it's not a easy conversion, then you can just use map function. So this is how you take analog input from Arduino and maybe use PWM over here. PWM to control a LED brightness. PWM is pulse width modulation, so you will be learning more about it. So this PWM signals can be used to control the brightness of LED, as simple as that. to even controlling the speed of motors and other devices, and even in many of the sensors and other things. We will know about it later, and this is how we use serial monitor. Okay, so this is the basic intro that you require when you use Arduino. Okay, so we will be interfacing Arduino with different sensors from now, and we will be using most of these functions, and also some actuators there also you will be using these functions. Okay, thank you.